Okay, in this video I'm going to be talking about how to calculate the average rate of change of a function. I want to stress for anybody that might be watching this out on YouTube or wherever you're watching this video that I'm making this for my college algebra class. This is not a calculus class. I'm not going to be doing any calculus in this. For the function f of x is equal to 3x minus 2, which we know is just a line, right? Y equals 3x minus 2. I've been asked to find the average rate of change between x equals negative 1 and x equals positive 2. I want to point something out before we go any further with this problem. See, this whole phrase here, average rate of change, is really just a fancy way of saying, what is the slope? What is the slope between these 2 points? The point negative 1 and the point 2 for the x coordinates. And if I want to find the slope, then that means I need to know the rise and I need to know the run. And if I want to know the rise and I want to know the run, that really means I just need to find two x, y coordinates. And the two x coordinates they're telling us are going to be negative 1 and 2. So I know half of what I need to know right now. I need to know then if I put a negative 1 into this function, what am I going to get for a y coordinate? This is really y equals 3x minus 2, right? And so I'm going to go through, I'm going to just plug it in. Instead of 3x minus 2, which is what I have, I'm going to put 3 times negative 1 minus 2, which becomes negative 3 minus 2, which is really negative 5. So an x coordinate of negative 1 gives me a y coordinate of negative 5. There's the first point. Now I'm going to go do the same thing. The second x coordinate they want me to find the slope between is negative 1, negative 5, and then 2 something. Sorry about that. So if I go through, and the equation is 3x minus 2, so if I replace 3 with a 2, if I replace the x with a 2, then I get this. 3 times 2 is 6, so I really have 6 minus 2, and 6 minus 2 is 4. So the second point that I'm trying to find is 2, 4. Now my job is to find the slope between these 2 points. And I know we could do y2 minus y1 over x2 minus x1. I've always thought that it's easier to draw a picture. My brain is just a visual. I can pick up pictures faster than I can pick up on formulas. Plus, I find that my students mess up formulas. So I'm just going to draw a quick sketch here. I see that negative 1, negative 5, you know what, it's going to be somewhere down here, right? So there's point A, if we want to call it that. And point B, which is 2, 4, is going to be somewhere over here. It's going to be up here. We can call that B, right? And I need to find the slope between those 2 points. So if I want to find the rise over the run of this particular line, it's going something like that, then I need to know how far did I go up and how far did I go over. I can see right now it's going to be a positive slope, right? And so I look at just the y coordinates for the rise. I look at the y coordinates and I know that this one here is at negative 5 and this one here is at positive 4. So I can see that I went 5 spots up here to 0 and then I went another 4 spots to the positive 4. That means I went a grand total of 9 for my rise. My x coordinates, I was at an x coordinate right here of negative 1 and I went over to an x coordinate of positive 2. And so I know that I went 1 spot to the 0, to the axis, and then 2 more spots. That's a grand total of 3 for the run. And so if my slope, m, is rise over run, that means that it is 9 over 3, which reduces to 3. Oh, weird. The slope of the line y equals 3x minus 2 is 3. Maybe we should have expected that, right? In fact, there's something important that we can take from this. If you can remember, if you can find a way to remember that average rate of change means the slope between 2 particular points. If we talk y equals mx plus b, you don't have to do any work. It's 3. If I give you a straight line equation, it's always just the mx plus b, it's the m. So let's go through and let's do one here. You might see the problem with this one. In this problem, you've been asked to find the slope of this line y equals x squared plus 2x. And so I just want to show you a quick picture of what that might look like. Here's x squared plus 2x. And immediately the problem is this. If I ask you what the slope is, that's not an easy question, because over here the slope is negative. And over here it's still negative, but it's not quite as negative, right? See, I'm starting slow. I'm starting pretty steep over here, but as I go along, I start to flatten out, don't I? And in fact, some point down here in the middle, I have a slope of 0. It flattens out completely. And if I ask you 2 points on the right, then you would tell me it's a positive slope. So the slope is always changing with this graph. It's a parabola. It's a curved line. It doesn't have the same slope. That's why we need to know the 2 particular x-coordinates and the y-coordinates. So if I tell you 2 x-coordinates, say for instance 2 and 4, then we're saying if I pick the x-coordinates for 2 and 4 out and I knew their appropriate y-coordinates, then I'm just going to pretend like there's a line that fits those. So like maybe here's x equals 2 and here's x equals 4. I'm going to pretend like if I fit a line between those, that gives me a pretty good approximation of what the slope is at that point. So my job is not any different. See up here, we said the first thing we need to do is find the x, y coordinates first, right? And then we're just going to draw a picture and we're going to pretend like it's a straight line between those 2 points. We're going to find the rise over run, and once we calculate the slope, then we're done with the problem. So the 2 x, y coordinates we have so far are 2 something and 4 something. If I put in 2 into this equation, that becomes 2 squared plus 2 times 2. X squared plus 2x. That would become 4 plus 4, which is 8. 2, 8 is a point on this graph. If I put in a 4, it becomes 4 squared plus 2 times 4 instead of x squared plus 2 times x. 4 squared is 16, 2 times 4 is 8, and 16 plus 8 is 24. So I have the point 424 in my graph. Now once again, you could do y2 minus y1 over x2 minus x1. I really don't care. If it works for you, it works for you. But like I said, I've always been a visual person. I like to be able to see things. I know that 2, 8 is going to be maybe over here. Let's say right there. Maybe that's 2, 8. We'll call that point A, right? There's point A. Here's point B, 424. It's going to be a little bit farther to the right. It's going to be a heck of a lot higher. We'll call that point B. And I'm going to pretend like there's a straight line that goes between these 2 things. And I need to find the slope of that line. So the question is, how far did I go up and how far did I go over? We can see right now we should expect a positive slope. Well, it looks like I started at a height of 8 here and I finished at a height of 24. To get from 8 to 24, I had to go up 16 spots. 24 minus 8 is 16. So there's my rise. I had an x-coordinate here of 2, and I finished at an x-coordinate of 4. So I must have went over 2 spots. There's my run. Slope is rise over run, which is 16 over 2, which simplifies down to 8. The average slope between the points 2 and 4, the average rate of change between 2 and 4 was 8. Hopefully that's enough to get you going on the homework. The homework problems aren't any tougher than this, okay? And if there's any issues, you can talk to me whenever I get back to school.